Straight A programming. In a previous video, I talked about process creation, coordination, and termination using the fork process and with some other process APIs. I'm going to talk a little bit more detail about some of the process monitoring that goes on with the operating system. So let me show the code I wrote for this. So basically, I'm going to talk about the wait, um, waitpid. Talk about some of these macros that can interpret some of the termination status of the data. So okay, so the first function I created is create child and wait, and so I create a child process with fork, and all this does, the child process just prints this. Sleeps for sleep is like a way for a process to do nothing and just, but it's running, and then exit normally, exit 0. And now in the parent process, when the PID that's returned from this fork, so now there's two. If you didn't see the previous video, there's basically two paths. After this is called by the original process, which is the parent process. If this value of PID in the if statement is 0, then it's the child process now. And if the PID is greater than 0, it's going to be the parent process. So I create this W status variable for the termination status. Like, it's going to terminate normally. So that's what this is going to be. That's what this is, terminated PID and wait. Now, wait is a blocking wait. This is inside the parent process, the original process that created the second process. So wait and W status at the address, the ampersand is at the address. Basically, inside this variable is going to go the termination status, and it's waiting for the first. So it only created one process, but if it created 10 processes or a bunch of processes, the first process that terminates, that's what's going to go here. That's what it's waiting for. Just any process that stops, that it created, any process that stops, it's going to get why it stopped, the termination status, and it's going to get the PID of the process that stopped. So if I created a bunch of processes, it's going to be the first one, and it stops. The parent process stops what it's doing. It just is in limbo until a process returns as terminated. So this is a blocking. Now, now these macros in C, you put the termination status, the value of the termination status that was returned, and it's going to interpret. Basically, there's a value in here, and it's going to interpret it. And I print out what the interpretation is. So the second one is very similar, but this is, like I was describing, if there's a bunch of processes, this wait PID is going to wait for a specific process. So you can have the original process waiting, the original process or parent process, you can have it waiting for a specific process instead of just the first one up here. That's the difference. So everything does the same, and the critical different code is wait PID, and it has it's going to be waiting for the PID that's returned. Remember, in the child process, the PID that's returned is 0. So this is going to be 0. If 0, then it's going to be the child process. And you can do all kinds of work in here. I just put sleep and exit and print. But you can do all kinds of things inside here. Okay, it could be a whole other file, you know what I mean? So I just did something really quick. And then this is the parent process when the PID that's returned up here in the fork is greater. Actually, excuse me, when, yeah, so what happens here is this is the parent process. It returns the PID of the child, which is greater than 0, and then it creates another process, PID2. And then it goes into another if branch, and this second process right here that the original process created just does some work like the first one. But now I coded it to where it waits, but not for the first one of these two processes. It waits for the second process it created. So it stops until um, this second process returns with the termination status. And so the termination status is given to the macros to determine if it, and it's going to return normally. Those are stopped normally. So, and now the first two wait and waitpid are blocking. They stop the original process and make it wait for a process to return that it created. This one's a non-blocking. So the parent process is going to continue. When it creates a process, um, it is going to continue, and you do that with waitpid and use the this flag. WNOHANG is a flag. So it looks similar, waitpid, and you got the pid of the process that it's waiting for, and the termination status is going to be put here. That's for the macros to determine how it stopped. But this flag is telling it to keep doing its work. So it can keep doing its work, but it's going to check to see if this process is done. It might be a value that this process is creating, is doing something that this needs. So it's waiting. So it's going to keep doing its thing. And in this situation, one of the easiest things is just have it in a while loop, keep going in a while loop, and it's just going to keep printing this as it waiting for this process to finish and return. But the main difference is that this parent process is continuing to work and do things, and it's a non-blocking wait like the other two were blocked. The parent process, the original process, just stopped doing anything until the the created processes, one of them returned. So this is the macros that interpret it. And I'm gonna talk about one more thing. Like, I know I didn't go into detail about the macros too much, but like a signal can stop the process, so it can come back and say it was terminated by a signal. Like if you go into Task Manager and stop a process that's taken up a bunch of memory, it's like sending it a signal to force. So this is a zombie process. What a zombie process is when, like before, I got the termination status each time in these previous functions. This is when the parent process creates a child process. Child process immediately exits, right there, stops. So there's a termination status. That's it's a process table that the operating system keeps track of, and this creates a zombie process because the operating system still has the process, this created process listed, but it's not doing it. It's stopped. It doesn't work. So when the parent process gets the status of this, um, it uses a command here to get, it uses the PID that was returned in the fork, which is the child process, the process it created, but now it's stopped already. Okay, so it's in zombie status. So when this returns, it's going to be Z as a zombie, and so it waits 15 seconds and does it again, and then finally it it prints it out, and then to clean up. So now what the process could clean up by calling wait null, and that cleans up the zombie process. So that fixes the issue, and You don't really want zombie processes. You don't want processes that are taking up resources that aren't doing anything. So that one little process isn't a big deal, but it's good to make sure that um, there's no lingering issues with stuff. Everything's closed, everything's finished. So so that cleans it up, the zombie process. So normally like you would get the status and that would be it. But in this situation, I created this on purpose, the zombie process. So I just call these each of these functions. So I'll run it. So the first one is just create the process and create the process and the process that was created terminated normally, and there's the PID of the parent and the process, the child process it created. This one is it waiting for a specific process. This one is non-blocking, so you can see that it's the original process continues to do things um, while the specific PID returns. And then this is the zombie process. You can see checking the status is Z. So Z plus is a zombie, and so that's it. Like I said, there's other things that you can practice, and but this gives you a general idea of monitoring how the operating system can monitor um, processes it creates. Thank you.